Good morning. Hope you're all doing well. Feeling this was going to happen. Okay. Sorry, my pen, the stylus to my Wacom pad has been giving me a really hard time because my Wacom pad is from like 2004. So if, which is a long time ago now. I still feel like we're in 2004, but we're not. So if you see me struggling with writing and stuff, that's what's going on. I'll try and get it fixed for next week. Figure something out, okay? So we've started to get into chapter 5 on naming and nomenclature, all that fun stuff. So we had left off talking about, we talked about polyatomic ions and how to combine them in an ionic compound. I have nothing on my board here. Let's see. That is what we had done. Great, yeah. So let's just do a couple of these to reignite our chemistry brain. Let's say we're going to combine lithium and carbonate. Calcium and let's do something fun, cyanide. And aluminum and sulfur. No E on sulfur in this. There we go. Ah! You guys work on those. I need to move my internet booster closer. Okay. Sorry, that's my French bulldog. He's got like a little bit of congestion right now. It's colder weather. Okay, so lithium and carbonate. So lithium is a metal with an Li and a plus. Carbonate is a polyatomic ion, CO3, 2 minus. The ATEs should indicate that you're dealing with polyatomic ion. Now there are some polyatomics that don't end in ATE or ITE, like cyanide or hydroxide. So this has a 1 charge, this has a 2 charge, so we're going to flip flop. So I need 2 lithiums for every 1 carbonate. I don't put the carbonate in parentheses because I just have 1 carbonate, so I don't need to. This next one, calcium cyanide. So calcium, Ca with a 2 plus charge. Cyanide is a polyatomic ion that you haven't seen, or we haven't really used in class, Cn minus, but it will be available on any polyatomic ion list. So it's a carbon, it's a nitrogen, and the thing has an overall minus charge. From here, we're gonna flip flop. So we have 1 calcium, and we're gonna need 2 cyanide. So I'm gonna put cyanide in parentheses and stick a 2 on the outside. This last one here is not even dealing with a polyatomic ion, it's aluminum, so Al with a 3 plus, sulfur with a 2 minus, and we flip flop Al2S3. Okay. So hopefully that feels easy. I want each of these steps, like we go over enough of it to get it to feel easy, because once they all get thrown together, it gets more complicated. So back to the slides. Okay. So what is nomenclature? Nomenclature is just a way of saying naming or naming compounds. Chemists had to develop some sort of systematic way to name compounds because in the universe, right, there's only 118 elements. You could work on memorizing those. But there are thousands and thousands and thousands of compounds. That is not necessarily something you'd be able to memorize. Now, chemists that work in a specific field, let's say they work with hydrocarbons or things like that, can start to memorize them. But in general, for the broader world, we needed a systematic way to name them. So in this way, if you learn the rules for naming, you will learn the rules that you'll be able to name pretty much every compound that's in. We're not doing organic stuff. That's a totally different way of naming. But you'll be able to name almost any inorganic compound. You'll be able to determine the name, and you'll also be able to figure out the formula. You'll be able to flip between those two. Now know that a lot of compounds do have common names. So H2O is systematically, we would name that as dihydrogen monoxide. But we don't call H2O dihydrogen monoxide, we call it water. So this would be the common name, this would be the systematic name. A lot of compounds do have common names that people just get used to using for different ones, but this is where I'm going to be testing you. Is obviously I need you to know that the common name for water is water, but outside of that, you have to be able to name them using the systematic name. They had, I remember seeing one of those like YouTube videos where like, they went out into the crowd to see, you know, how intelligent Americans really are. And they said, do you know that they're putting dihydrogen monoxide in your water? And all these people were so appalled by it, and they were signing this thing, not realizing that dihydrogen monoxide is in fact water. So if anyone ever walks up to you on the street and starts ranting about something with the camera in your face, just don't say anything. It's probably for the best. Don't say anything. Just turn around. Okay, so common names are learned through familiarity. Systematic names, you just need to learn the system. So let's learn the system. Naming ionic compounds. I'm going to skip to the very last page of this slide. Right here, okay? This is pretty much the entire second half of the chapter, all summed into one. But I want to get a starting point with how we're going to name. So the first thing you have to do is determine, is it ionic, is it molecular, or is it an acid? When dealing with something that's ionic, we are going to have a certain way of naming that is different than if it's molecular, and it's different than if it's an acid. So the first thing when you go to name something is figure out what the compound is, divided into ionic, molecular, or acid. Now, ionic, remember, just means that it's a metal combined with a non-metal. So if that first thing listed is a metal, you 99.9% sure can say it's ionic. Molecular is going to be two nonmetals, and then an acid is going to be where we have H sitting in the front. So like HCl or HBr or HSO4, something where the hydrogen is coming first. Okay, so we're going to talk about this right here, this ionic section. And at this point, you know how to write formulas for ionic stuff. But we haven't yet come up with the names. So first thing when naming ionic compounds is identifying that it is in fact ionic. If it's not ionic, don't use these rules. So a metal combined with one or more nonmetals in its chemical formula, you can assume it's ionic. The next step, once you have determined that it's ionic, is you have to break it up into either a type 1 or a type 2. Type 1 is a metal that forms only one type of ion. Type 2 is a metal that forms more than one type of ion. And when I say that, I mean, does it have a predictable charge? Type 1. Does it have an unpredictable charge? Type 2. So predictable charges, hold on, sorry. Grab my formula sheet. All right, so remember that the predictable charges for metals are going to be the things in column 1 and in column 2, aluminum in column 3, and then we've got that zinc and silver, right? All the rest of them are going to have unpredictable charges. So let's start with the easier one if it has a predictable charge. The first type, called type 1, contains a metal with an invariant charge or a predictable charge. Second type is got a variant charge, usually the transition metals. Here it gives you a little bit of information. So some transition metals, zinc and silver, have predictable charges. So you should already have that written on your formula sheet. If you don't, next to zinc, put a 2+, and next to silver, put a 1+. Okay. Some main group elements have varying charges. So lead and tin, or Pb and Sn, those have varying charges. Well, it is what it is. Okay, so there's our predictable charges. Here we go. Scandium, sometimes predictable charge of 3+. I mean, there's other ones that can have predictable charge, like gallium, cadmium. Really, if you know that these two have a predictable charge, that's going to, along with the main group elements, that's going to take care of you. Why is beryllium and hydrogen not included in that? Because those guys are such small atoms, they can do kind of funky things. Like hydrogen can take an electron, sometimes it gives an electron, so we don't always include them. And if hydrogen is acting as the metal, then we call it an acid anyway. All right, so here are some of the varying charges for transition metals. So chromium can have a 2+ or a 3+. Iron can have a 2+ or a 3+. Tin can have a 2+ or a 4+. Do you have to have all these memorized? No. You'll always be able to figure out the charge, okay? So the way that it's written will identify which one you're dealing with. So if I'm dealing with chromium with a 2+ charge, I am forced to write it as chromium with a Roman numeral 2. Right? If it's chromium with a 3 plus charge, it's going to have chromium with a Roman numeral 3. All right, there'll be a Roman numeral that comes after it. The Roman numeral tells you the charge, not how many you have, the charge. All right, so over here we've got tin with a 4 plus charge, so it would have tin with Roman numeral 4. Okay, so back to if it's a predictable charge. If it's a predictable charge or a binary ionic compound, the way you're going to name it is you say the name of the cation. So you say the metal first. Then you take the base name of the anion, and so you cut the end of it of the metal, or the non-metal off, and you IDE the end of it. Now with the metal, because the metal always has the same charge, you don't need to let the reader know what the charge is. You don't have to call it lithium 1. I know lithium is always going to have a 1 charge. So I would say lithium sulfide, IDE. So here we've got one. So we don't call this thing sodium, I'm sorry, we don't call this sodium chlorine. We call it sodium chloride. So we take the ending off of the chlorine and we replace it with IDE, just how it is. Here are all the base names for the common nonmetals that you're going to see. So fluorine goes to fluoride, chlorine, chloride, bromine to bromide, iodine goes to iodide. It sounds kind of weird. Oxygen does not go to oxygenide. It goes to oxide. Okay, so you cut quite a bit of the oxygen off. Sulfide and nitride. So if you're seeing the fluor, like for instance, sulfide, you're seeing it ending in the IDE, you're talking about the element, not the polyatomic ion. So I'm going to write a couple things out here. Now you've got things like sulfur, sulfide, sulfite, sulfate, sulfate. Okay, oh my goodness, all these things look very similar, and sometimes the beginner's mind is like, oh, it's sulfur, right? They're sulfur, I don't know. They're different things. This is sulfur by itself. This is sulfur combined with something in an ionic compound. This is sulfite. This is a polyatomic ion, SO3 2 minus. This is a polyatomic ion, SO4 2 minus. You see how just a little change in some of the lettering has a huge effect. So if I say something like, hey, sodium sulfide versus, hey, sodium sulfate, those are different things. So lots of details happening with nomenclature. I don't want you. Okay. Now, if we have a varying charge, you have to let the reader know when you write its name, you have to let the reader know what charge you're dealing with on the metal. It's not enough to just say iron oxide. Iron oxide is a group of compounds that have iron and oxygen. Because iron has a varying charge, you have to specify which charged iron you're dealing with. So when we do that, we're going to say the name of the metal. And so here's an example of if copper has a 1 plus charge, we would write it as copper Roman numeral 1. If copper has a 2 plus charge, we would write it as copper Roman numeral 2. So the way you write this, it's very similar to the other one. There's just one additional step. So we take the name of the cation metal. Then we have to include which charge we're dealing with, the base name of the anion, and we ide it. So iron to oxide. You can't just say iron oxide. It's not enough information. But let's do some of these. Let's do the simpler ones first, and then we'll come back and I'll show you how you can get the charge. Okay, I'm gonna write, share screen. I'm gonna write some formulas, and I want you to tell me what the name is. Okay, so okay. So when looking at these, the first thing again is to identify that they are in fact ionic. So all of these are ionic. The first thing is a metal. If I had written something like CO2, we are not going to use this technique for naming that. We use something different. So this first one is calcium. We name the metal first. And then we've got bromine, which becomes bromide. Calcium bromide. This one here, we've got sodium nitride. Rubidium sulfide. Lithium chloride. You don't need to say, you know, sometimes people say, well, but I've got 2 of these or 3 of these or 2 of these. You don't need to specify that. With doing nomenclature, the goal is to write as few things as possible, but to preserve all of the information. So do I need to say that I have 3 sodiums? No, because sodium always has an Na with a plus charge. Nitrogen, nitride, always is N with a 3 minus. If I flip-flop, the only thing I can ever come up with, Na3N, is this formula. So this is enough information to get back to this. But you don't need to say what the charge is. You don't need to say how many of them there are. There's only one way to go back and forth in this case. Now that gets a little bit more complicated when we have a varying charge. Okay. So let's look at FeCl3. I'm gonna go to the other. So we'll do FeCl3. I need some purple in my life today. Okay, FeCl3. So we want to name this thing. So when I go at these, first I want to identify it is a metal and it is a non-metal, and it's a metal with an unpredictable charge. So I'm going to need a Roman numeral. So what I'll do is I'll write my metal. So in this case, it's iron. I'll put in the Roman numeral because I'm going to come back, or the parentheses because I'm going to come back to it, and then finish off with, that's chlorine, so it becomes chloride. So I'll just start there to kind of get my brain going. Now, I need to figure out what the charge is on this iron in this formula. Well, we go from what we do know to get what we don't know, okay? So I kind of make a line in between where my metal thing is and my non-metal thing is. This overall compound has a 0 charge, right? Metals and nonmetals come together to form a net 0 charge. So all the nonmetal stuff needs to be equal and opposite in charge to the metal stuff. So what is the charge on chlorine? Always -1. And how many of them do we have? We have 3. So we get a -1 charge times 3, which gives us a -3 charge, okay? If this is -3, what does this side have to be to balance it out? Equal and opposite. So 3 plus iron 1, 2, 3. We're dealing with iron 3. So you go from the nonmetal, which will always have a predictable charge, or it'll be a polyatomic ion, which has a predictable charge, to get the metal with the varying charge. Let's say I was to do this formula very similar, but instead of it being FeCl3, it was FeCl2. Okay, in this case, sort of separate it out. Chlorine has a 2- charge. No, don't listen to anything I'm saying. Chlorine does not have a 2- charge. Chlorine has a 1- charge. 1-, but we have 2 of them, right? So it's an overall 2- charge. This whole thing has to equal 0. So this has to be a 2+. So this becomes iron 2 chloride. So these are a family of iron chlorides, but they have different charges. Let me see what's in the comments here. You only show the Roman numeral with unpredictable charges. Yes. because let's write Li2S. Okay. Lithium sulfide. Why don't I put it as lithium 1 sulfide? What is the charge on lithium always? It's always 1. Yeah, it's always 1. So we don't need to include this information. It's more information than needed. If it's lithium, it's always going to be a 1 charge. And scientists are lazy, so we want to use as little information as we have to portray what it is. So lithium sulfide is going to be more than enough. Just for fun, why don't we complete our little trio here and do FeCl. If you can come up with the name of that one. Probably can see the trend happening here. So chlorine is a -1 charge. We only have 1 of them. So when you're going from the element up to the charge, you multiply. If you're going from the charge down, you'll divide, and we'll do one of those in a second, but there's only 1 of those. This whole thing has to equal 0. So this needs to be a +1. So we're going to go with iron 1 chloride. So I hope now you're starting to see why if I just wrote iron chloride and I said, write the formula, what are you going to do? Can you write a formula? You're going to go look at your periodic chart and you're going to say, okay, iron, I have no idea what charge you are because you're sitting somewhere in the middle. So this would be incorrect. That's why you've got to give me a Roman numeral in there. Right? So I really like nomenclature. I really like this chapter, both in regular chemistry and organic chemistry, because I feel like this right here is what ends up intimidating people from chemistry. They're like, I don't know what all these compounds are. This is so confusing. But if you learn the system, I think a lot of the rest of chemistry becomes really, really accessible. And it also makes you sound really, really smart too, when you can be like, oh, that's dihydrogen monoxide. Oh, that's iron 2 chloride, not iron 3 chloride. So, it's a good chapter to know. It's a good chapter to know for sure. Let's see if this has any more hidden gems in it. Okay, iron 3 chloride, we got that. Polyatomic ions, we're not gonna do that. Okay, I'm gonna give you some more of these I'm gonna just mix a bunch of things together. And then I want you to name all of them. So let's clear this out. Okay, so I want you to name all of these. I'll give you about, hello, let's bring that back up for you. We'll give you until like 8:45. Okay, so you have 8 minutes.
CA3.
Sorry, what was that?
Is the third one CA?
It is in fact CA3N2. I know it's sort of unbelievable, but yes. Let me try and clean that up a little bit. CA, come on, you can do it, Candace. CA3N2. Okay. Okay. So looking at this first one, I'll put a line between my metal stuff and my non-metal stuff. This is cobalt, this is oxygen. So I know it's going to be cobalt, it's going to have a Roman numeral, and it's going to be oxide. Cobalt sits in the middle, unpredictable charge. All right, oxygen always has a 2- charge. So that means the summation of the cobalts over here need to be a 2+. But how many cobalts do I have? I have 2 cobalts. So this 2+ charge is getting distributed amongst 2 cobalts, or you need to take whatever your charge is and divide it by how many of them you have. That's where I was saying if you're moving from here up, you multiply. If you're moving from here down, you divide by however many you have. It doesn't matter if you only have 1 of them, but in this case you have 2. So each cobalt contributes a 1+ charge. So this should be cobalt 1 oxide. If you're like, well, no, I don't like that. I think it should be cobalt 2. Okay, well, let's do that. Let's do cobalt 2 oxide. If I go ahead and try and get to the formula, cobalt, in this case, would have a 2+ charge. Oxygen would have a 2- charge. Flip-flop, it'd be CO2O2, which reduces down to COO. This is not the same as this. Actually, this is the same as this. So this is the name for the second one, cobalt 2 oxide. This guy here, calcium. Calcium has a predictable charge. So all I need to say for this one is calcium nitride. I don't need to do any sort of Roman numeral here. This one here, we've got tin. Tin has an unpredictable charge, nitride. All right, nitrogen is a 3- charge and there's 2 of them. So it's an overall 6- charge. So this tin needs to pack a lot of punch. It needs to be a 6+. So VI. So know your Roman numerals up to 6 or 7. This last one here, it looks like there's a lot going on. It's really just aluminum oxide. Okay, we don't need to include any sort of charge because aluminum is always a 3+. If I go backwards from aluminum oxide, will I come up with this formula? Yes, 100% of the time, every single time, as long as I'm doing it correctly. So to throw more in the mix, what do? There's a polyatomic ion. How do I name that? That's actually easier. Right. So some of them contain polyatomic ions, which are those groups of charged particles. Ionic compounds containing polyatomic ions will follow the same procedure, except that when you have a polyatomic ion, you just say the polyatomic ion's name. You don't shorten it, you don't truncate it, you don't change it. So this thing here would be potassium nitrate. I don't IDE the end of it or anything like that, just potassium nitrate. This thing here would be iron 2 hydroxide. This is hydroxide is the polyatomic ion name for that. If you have an instance where you have 2 polyatomic ions smushed together, because we do have a positively charged polyatomic ion out there known as ammonium, you would just say the positively charged and then the negatively charged one. So this would be ammonium nitrate. So this very complicated looking thing actually is quite simple. It's just 2 polyatomic ions smushed together. Before we get into some practice with that, let's look at where these polyatomic ion names are coming from, just to kind of help you get some understanding. So many of the polyatomic ions that we see out there are known as oxyanions, not all of them. Like cyanide, Cn- is not an oxyanion. In order for it to be an oxyanion, it needs to contain oxygen. When a series of oxyanions contain different numbers of oxygen atoms, they are named systematically as well, according to how many oxygens they have. If there are two ions in the series, the one with more oxygens is given the ending ATE. The one with the fewer oxygens is given the ending of ITE. So look over here. This one with 3 oxygens is nitrate. This one with 2 oxygens is nitrite. So I subtract an oxygen, the charge stays the same. I subtract an oxygen and I ITE it. Sulfate, it doesn't mean that ATEs have 3 oxygens though. It just means they have more oxygens. Because if you look over here, sulfate has actually 4 oxygens. If I want to get to sulfite from sulfate, I just strip an oxygen. Charge stays the same. Everything else stays the same. You just bump an oxygen down. So hopefully now that's making a little bit more sense, the ATEs and the ITEs. If you know your ATEs, you can really easily figure out your ITEs by just pulling an oxygen off. If you deal with a series that has more than 2, like let's say you have a series of 4 here. So this here, the ones on the edge, so in the middle here, I've got my 3 oxygens, that's chlorate. If I strip an oxygen away, it becomes chlorite. If I strip another oxygen away, it becomes hypochlorite. Hypo meaning under, right? Hypoglycemic, yeah. If I'm at chlorate and I want to add another oxygen, I become perchlorate. Okay, the per meaning that we're adding something. So this is actually where I spent most of my time in graduate school, was working on perchlorate contamination. So I know this compound very intimately. That tends to be the case. It's found in, let's see, it's found in fertilizers and also found in rocket fuel. A lot of times things that are fertilizers are really great explosives or propulsion products. So I was looking at contamination of this in the Great Lakes from specifically seeing if it was coming from Lockheed Martin, which is a government-run company that makes a lot of different sorts of explosives and planes and things like that for war. So, all right, over here we've got the bro series, the bros. So we've got bromate, we've got bromite. Strip another one down, we get hypobromite, perbromate. You're starting to see hopefully the series, and then we've got the iodates right over here. Iodate, iodite, sounds so weird, but so hopefully those are a little less intimidating, how those kind of connect to each other. All right, so let's name, I'm gonna put some with polyatomics and I want you to name them. Maybe another minute, and we'll go over them. All righty, so that first guy, there's calcium with a polyatomic ion. If you're ever, when you're going through and naming these and you're like, oh my gosh, this has a plus charge, I don't know what's copper's, what's carbon's charge, and I don't, there's 3 oxygens, so confusing, it's probably a polyatomic ion, okay? 99% of the time when you're like, how do I do this? What's going on? I thought I knew the rules. It's a polyatomic ion. So in this case, we do have a polyatomic ion right here, this guy. So I've got calcium, which has a predictable charge, so I don't need a Roman numeral, and then I just name the polyatomic ion, which in this case is carbonate. You're done. This next one here, again, if you get to a place where you're like, I don't know what I'm doing, and right now, obviously, because we're in the polyatomic ion section, this all makes perfect sense, but when they're all thrown together on an exam, you find yourself getting stuck, you're like, there's more than 3 elements, I don't know how to do this, it's a polyatomic ion, look at the sheet. So in this case, I've got cesium. Does cesium have an unpredictable charge? No, it doesn't, so I don't need a Roman numeral. And that second thing is sulfate. And we're done, cesium sulfate. This guy here, okay, I've got titanium. Titanium does not have a predictable charge, so I'm gonna throw a Roman numeral there. And this thing over here is sulfite. If I know sulfate, I can find my sulfite or identify it. So that's sulfite, I-T-E. Sulfite always has a 2- charge. So the titanium needs to have a 2+, but it's distributed over 2 titanium. So each titanium has a 1 charge. Titanium 1, sulfite. Last one here, I've got copper. Copper is in the middle, unpredictable charge. And then this thing over here, which is known as phosphate. Phosphate always has a 3- charge. I'm not pulling that out of thin air. I've just done these polyatomic ions so many times, like so many times. You don't need to pull them out of thin air either. Have a polyatomic ion sheet. So 3- charge, copper in this case should have a 3+ charge. 1, 2, 3. Copper, 3, phosphate. So does anybody have any questions about that first part of naming or nomenclature? Obviously, outside of the fact that you just want to practice over and over and over and over again. I think with nomenclature, practice makes mastery. And it's a lot of little details where you'll be like, this is the kind of section where it's like, it's not enough to know it like 70%. You got to know it like 95% to get a pretty good rate, because there's these little exceptions here and there and little details. So if conceptually you guys feel good, then we'll be done for today. I don't want to get into nonmetals just yet. We'll talk about that next week, and we got more than enough time. We'll probably next week to do some of our lab, the nomenclature lab, together in class. Okay, so make sure on it's just literally it's just a sheet of formulas, and you give me the name, and a sheet of names, and you write the formula. So have that available over the next 2 classes, because we can chip away at that together. If you have any questions, feel free to stay around. Otherwise, if you are good to go, get off so I know who needs help. But it was lovely seeing you all. Bye.